Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is another video of me working in Go. So in the last video we talked about arrays, and again the big thing with arrays is that they're fixed in length. So when you declare an array, you can't really change its length later. You can create a new array, but what happens if I only want to work with a piece of an array, or I need something more dynamic in size? Well, the creators of Go, I mean, different languages have dealt with this in different ways. So like in JavaScript, arrays are just basically you don't have to worry about that. So under the hood, basically, essentially, every time you expand the size of the array, it's just taking up a new spot in memory. So basically, you had a 4-element array. It's in a 4-element spot in the array, and then when you pop it, or you push a new element to it, it's just going to go grab a new. But it's going to happen every single time, um, which can or can't be efficient in memory depending on how your program is programmed. Okay. Go aims to be, AIM was created not necessarily with just the web in mind, even though JavaScript and TypeScript, especially with TypeScript, has evolved beyond the browser and the web. But Go was kind of like, okay, hey, we want to make a cooler version, or like, something like C++ and Java without all the stuff we don't like about C++ and Java. So it has that sort of more granular level of memory management to it. But the goal was to make it less painful. So what they did is they created something called a slice. So a slice, what you're doing is that you're creating a reference to an existing array. So this allows me to create like so I could have 100-item array with 100 items in it, but I only need to do work on 2 items, and I can basically create a slice that's 2 items out of that array. So you still have the 100-element array, but this 2-item slice is only referring to those 2 items. You're still playing with that array, but that's kind of like a window to those slices. It's a pointer. So it's pointing to where in that memory. This creates a couple of interesting things to keep in mind when you work with slices. The other cool thing with slices is they can be dynamic in size. So if you create sort of a new slice from scratch without an existing array, it can be dynamic in size. You can add another element to it, and kind of like how I described before, it'll just delete your old array and then make a copy with the extra space to meet your new element in memory. Okay, so you had 5 slots, you had a 5-element array in a certain part of memory, but now you want to add a 6th element. It'll just say, hey, you know what? Let's just copy the first 5 elements over here, add a 6th spot for the new element, and now we're going to point to that array instead. Okay, so it's just going to create sort of new arrays for you on the fly, and then just become a reference to that array. Okay, so that's the concept of a slice. Okay, now the way a slice works, so let's see here, we have this 2-element array. So let's say I wanted to create a 1-element array, or 1-element slice. So let's delete all this. Keep my array. I'm going to say, now we're going to create a variable called my slice. My slice equals my array. And then what you have to do is when you're slicing a different array, you're going to use a semicolon. This represents the range that you're slicing. So the first is where you start. If you don't put anything before the colon, it starts at 0. And if you don't put anything after the colon, it goes to the end of the array. So I just want the first item, so I'm just going to do 0. Okay, so basically should only grab 0, or the 0 item. So let's make sure that that's the case. My slice, actually, let's say fmt print, again uppercase, and let's print my slice. Okay, let's run that, make sure that all went well. Interesting, printed an empty slice. Let's do it this way. Maybe let's see if I change this to 1. Okay, so in that case, it's not referring to the index, but the number of elements. So in that case, I'm saying end after the first element. Okay, so it's only going to copy the first element, 5. Cool. Okay. Another way you can think of it is up to, but not including that index, if you want to think about it that way. So there, I have my element 5. So that's the only thing in my slice. But it's not a separate 5. It's actually a reference to the 5 in my array. So if I were to change my slice, so if I were to go my slice 0 equals 10, okay, let's print my slice again. And then let's print my array. And you'll notice that my array has changed as well. Because again, the slice isn't its own separate data. It's a reference to the array. And I just want to kind of illustrate that point to get that point across. Okay, cool. So you see, and then actually let's print the array beforehand so we can see what the array was originally. So yeah, that over here. Run that again. So the array was originally 5, 6. I created a slice of the first element, which is 5. I then changed the slice to 10, but again, that slice is a reference to the original 5, so the original array is also now 10, 6. Cool. Okay, so that's what a slice is. Okay, but I could create a whole new slice without creating any kind of, reference. So I could just be like new slice equals, and again, I'm using the quick assignment operator because this means I don't have to spend too much time doing typing up a lot of stuff like var and all that stuff. So my new slice, not new slide, new slice is going to equal, you put an empty bracket, so that means I'm creating a slice because I'm not specifying how big it's going to be. A new slice of type int. Cool. Okay. So now, if I hit run, no, that's not going to print anything. That's fmt dot print new slice. Now what that does, it's going to create a new array. So there's technically this new empty array. The only thing is that there's no variable name for me to directly access that array because I never declared it as an array. Instead, all I have is a slice which is the reference to where that nameless array is hanging out. Okay, so if I run this, should really get, see here, int is not an expression. Okay, so that doesn't work. Reason being is that if I'm going to declare a new slice this way, I got to give it some values, and the way you do that is with some curly braces. Okay, which would give me, let's say, we'll say let's put 33, 44, 55, 66 in my thing. Okay, and now we can print out the new slice. So, whoa, wait, no, semicolon shouldn't be there. There we go. Okay, and so there's my new slice referring to a 4-element array. And so you notice I didn't have to tell it what size I want it to be in the square brackets because I'm creating a slice, not an array. An array is created vicariously because a slice has to refer to an array, which is really cool. So now when I create a function, I can create a function. So actually, here's my array, my function, or my array magic function that we did before. Okay, and instead I can change this and take that out. So what does that mean? Okay, what that means is that now what it takes as an argument is a slice of an integer array. So it doesn't matter how many items it has. Okay, so now I can use the same function for a bajillion item array or for a 2-function array. Okay, which is cool. Now here's the catch. If the parameter, so the array variable, is technically, the slice is technically a reference to the array. So if I start modifying, in this case, I start modifying it, it's actually going to modify the original array. So in this case, like before, when I used the function, it didn't change the original array. This will. So now let's try this out. So now if I go back to use my magic, actually we haven't used it because I deleted it from the previous video. So let's give it a shot. So format print, we're going to use it on both. We're going to use it on both arrays that I have outstanding right now, my 2-item array and my 4-item array, and this should work on both, okay, because I'm going to do it via their slice. Okay, so in that case, I should be able to do array magic and call. First, we'll do my original slice, my slice, and then I will do the same with new slice. Now in this case, these are both going to print what the function returns, which is the edited array. Okay, but what I'm going to do is then let's do this. I'm going to print out just the slices afterwards, just to kind of show that they have actually been changed. Because again, you don't want to accidentally be changing your data when you don't want to, so you want to be very careful. How you would avoid this is that what you would do, I'll show you in a second. First, let's do this. Okay, save. Well, I don't need this, it's automatically saves. So now if I run this, boop, 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 boop. Okay, bad time, runtime error, index out of range. So when did that happen? So let's run through this. Okay, so the first print, it prints my array 5, 6, which is the 2-item array. We're right over here. Then it prints the item by itself, my slice. Again, then we change my slice to 10, which changed both. Okay, then we print. Okay, we printed that out, which is the 4-item new slice. And then it freaks out when I call my array magic function. I see. So the issue is, so the reason why this errored out, what I forgot is that technically we only sliced one element here. And technically, this function is going to try to edit 2 elements. So let's get rid of the second one. So that way we shouldn't run into that error. So basically all this function will do is change the first element of both arrays, or both slices. So let's run that again. So this time it works. Okay, so let's run through that. So again, first it prints out the original 2-element array, 5, 6. Then I slice the first element, 5. Then I change the slice to 10, which also changed the original array. Then I created a new 4-element slice. Okay, new 4-element slice. And then I ran array magic on the first slice, which means it was a 1-element slice. So basically just returned 1 element, that's 7. But if I print out and then again, it does the same thing for the 4-element slice, new slice. But then if I go back and print the original slices, see the slices are changed despite the function. Okay. So if you watched my video on arrays, remember when it was arrays being passed through to the function. Okay, and then if I went and printed out the original array, so let me print out the original array so we can see that changed too. So see, just want you guys to see that, you know, it all changes each other. It all is mutating. Okay, so we go back to the 2-element array, see that changed to 7, 6. So when I change that slice to 7, it changed this array over here as well. And the function made the change. So when I did just the array, when I passed through an array in the previous video, okay, it didn't change. When I did this, it didn't change the original array. So how would I avoid this? So if I'm working with slices, because the benefit of being able to make a function take a slice is that I don't have to worry about how many items there are in the array. Okay, and I can make a function, instead of having to make a function for every size array, I can make one function that works for all arrays. But what if I don't want to mutate the underlying array inside the function? Okay, because I can get sloppy. Well, the simple fix is to do this. You create a second array. So array 2 equals array. This way, what happens is that you now have a copy of your array in the beginning. Well, let's see if that works. Okay, and then what I do is I change that array 2, and pass, and then return array 2 instead. So in that case, we should still see the change. Now, if I'm correct, we should still see the changes. when we pass the function, but the original array should not be edited. So let's see here. But I could be wrong. What could be happening is that when I assign array to array 2, I could just be making a copy of the slice, and then I'm back where I started. So let's find out. Undefined array. Oh, I got to declare the array. So let's do it this way. Okay, quick operator. Okay, so let's see here. Okay, so basically here's that, and yeah, no, it's still changing the array. So when I do that, all I'm doing is assigning the slice to another slice. So I got to figure out a way to make that slice an array. So what I would have to do is probably declare it as an array first. Okay, so let's, okay. So what we would do, so I'm going to solve this problem now. I'm figuring this out live here. So we'll create an array 2. That's going to be an array. Now the size of the array is going to be the length of the slice. So the length of array. Okay, and type int because we're talking about an int. Okay, so this way array 2 is definitely an array. And then I'm going to assign, then I'll do the assign array 2 equals array. So that way, since it's an array, it should be passing the values through, not the reference through. At least that's what I hope. So we'll see in the results if I am correct. Okay, so just to kind of walk through what I did is I explicitly declared an array. So here I'm declaring the length of the array dynamically by using the length of the slice. So whatever slice you pass through, this will automatically create an array that's the exact same size. Okay, constant array bound. Let's see here. That apparently has to be a constant number. Okay, so okay. And I think a lot of the things with constants is a lot of things that are, certain things have to be constant in Go, which wouldn't have to be in something like JavaScript, because what happens is that these programs are going to be compiled. So certain constants have to be already known at the time of compilation. So that's why if you declare a variable a constant, you can't have a dynamic variable as a constant. Like I can't put len array and assign it to a constant array, a variable that's constant, because it would screw up during compilation, because it may not know what that is to make that constant in the code. Because usually when you declare a constant, what it does, it just fills in that variable at compilation time across the whole program. It can't do that if it doesn't know what it is at the time of compilation. So that seems to be sort of the problem it's giving me now. It's like it doesn't know what it's making. So what we're going to do, I'm going to make it a 2-item array. Okay. And so it's a 2-item array. Actually, let's make it 4 items, and then we're only going to call it on the new slice just to see if it works. Okay, so I'm going to comment out the references to my slice using the function. And again, I can just comment things out really quickly by hitting Control/. Let me run that. Let me just go back and take a look, make sure that looks all good. For int array 2, yeah, that's fine. Can I use type int as type an assignment? Okay, so you can't assign a slice to an array. Assignment cannot use array 2. Oh, the solution is clear. Okay, you just create a new slice. So I'll just do the same thing again. Okay, so what we would do is we would create array 2, which is going to equal quick operator, a new slice of type int, and then we'll just give it 4 zeros. Okay, so there's my 4-item slice. So now they're both slices and they're both size 4. Okay, just to make sure that it all meld together. See if this works. This should prevent the original array from being, because when I create this new array 2 slice, it creates a separate array from what the other arrays were referencing. So let's see if that works the way I think it's going to work. Okay, 33. Nope, it just still copies over the reference. So, bottom line, looks like that's just something you have to be careful with when you're playing with slices. Okay, you can't assign a slice to an array, and if you assign a slice to another slice, it just copies over the reference. So you got to be very careful about how you mutate how you play with the array's values inside of a function, taking a slice to make sure that you're not manipulating the original array. Okay, we'll probably revisit how to sort of set up a function correctly to do that later on. I'm going to play with that. That's a fun challenge. Okay, but I mean that's the benefit, the big benefit of the slice as your parameter is you don't have to worry about the size of the slice. But you have to be careful with the function that it can work with a slice of any size. So you probably would want to use for loops using that whole sort of for I iteration type style that I illustrated in the previous video to make sure that no matter what the size of the slice is, you're good to go. Now, the only other thing I want to mention is that there's a function called cap. So length tells you the length of the slice. But what if you want to? But the thing is that the slice has a capacity, which means, well, if there's more elements in the array, the capacity is all the elements in that array that exists. So this slice here, okay, has only one element in it, but it has a capacity of 2 because the original array, my array, has 2 elements in it. So let's put that to work. So len my slice. So that's the length, the current length of the slice. And then let's print then the capacity of the slice. So that would be cap my slice. Okay, so that should be, where is it? What's this 12 here? It's not supposed to be 12. It's just because they're right next to each other. So basically the one is really 1, then 2. So 1 item in the slice, but has a capacity of 2. Okay, because it didn't include a space. But basically that's what it's saying. It's saying, hey, technically I could reslice this to make it 2. I could reslice the same array as many times as I want, and I can create multiple slices referring to the same array. So slices allow you to have a more dynamic thing. Now the last thing I want to show you is how you would add to a slice so that way you can increase its size. So this will be the last thing we do before we move this video, because this video ended up being really long. But slices are a complex and sort of newer idea. I don't think I've seen something like a slice in other languages. I mean, I guess if you were to create like an array of pointers in C++, that's kind of like this, but it's kind of like if it was it's built in. So essentially what's going on here is we're going to add to my new slice. So we're going to use, so we're going to say that new slice is going to equal append. So it's using the append function. I'm going to append the value to it. And again, I'm appending from the new slice, or I'm appending to new slice, and I'm going to append the value of 77. Okay, and then I'm going to print the new slice again. And it should now have 5 items. So even though it was originally, and again, I want to print the length of it both times too. So you can see that the length actually changed. So unlike an array whose length cannot change, you can dynamically change the slice. And what it does, it just, again, just creates a new array and refers to the new array. Versus, an array variable where you're literally accessing the array directly. Okay, and then I want to have another copy of this right after this. Okay, Let me just comment out some of these other prints, just so that way there's not so many prints. Cool. Cool. So let's see. First, we have our original slice, 33, 44, 55, 66. Then, which has a length of 4. And then we have our new array where we appended the 77, and now it's a slice of 5 length. So again, what it did is that when it appended 77, it just created a new array in memory, and the slice changed the reference to that new block of memory, not the old block of memory having 4 items. And then that 4-item slice just got garbage collected, which means it cleaned up the memory. Long as that's the only slice referring to it. If I have other slices referring to that same piece of memory, so let's say I created 2 slices to refer to that 4-item element, and then I appended to this slice, making it 5 elements, well, that old slice is still referring to that array, so now I have 2 blocks of memory being used up. So you gotta be very careful that you don't have multiple slices. Careful, you don't have multiple slices referring to the same, or multiple slices referring to the same array, because you can end up being very inefficient with your memory. So that's sort of the catch 22. So while that slice will make a new array and make you a dynamic thing that you can use size-wise, if you're not careful and you start just creating slices haphazardly and multiple slices for the same array, you could end up being very inefficient with your memory usage. So again, and then so that's why it's probably better to make your extra, if you need to make an extra slice, to do it within a function. Because again, variables that are created within a function, they all just kind of disappear after the function is gone. So in that case, since they don't really kind of exist anymore after the instance of the function, you won't run into the same issue. So again, it's just about tidy coding, especially when you're talking about memory intensive applications. So you're granted this extra level of flexibility. So you still have, the point is you have this trade-off. You have the sort of the memory management benefit of being able to define constant sized arrays, but you're given the extra flexibility with slices, but you got to be careful to not get messy. That's slices in Go. I'll talk to you guys in the next video. My name is Alex Merced from alexmercedcoder.com.